Okay, for this example, I need you guys to draw the two triangles that you see and label the triangles as much as you can. I want you to label the angles, label the sides as much as you can with everything you know. Try to label every single side for those two triangles. Here are the two triangles. There's a triangle right here, and there's a triangle right here. So you're going to have a small triangle and a big triangle looking like this. Small triangle, big triangle. Okay, label as much as you know. Here I go. I'm going to walk around and just see what you guys got. Very good. Some of you guys remembered our warm-up. Let's see. You should have a theta right here and a theta right here. And then you should also have the vertice labels. So that would be O, P, and then Q. And then you have the other one, which would be O, R, and then S. Okay. So give me one of the side labels. Let's see. You got one, Claudia? You got one? A side label? Just one side. Tell me one side. RS is, you said, was M? Or sine? Ooh, not sine. Sine isn't this one right here. This long one right here. Tangent? Yeah, look at you correcting yourself. Very nice. So tangent of theta, or you can write M, I suppose. I like tangent theta better. That's more specific. Lovely, you got one? Well, you went like this. You kind of raised your hand.
Oh, no, but I put OQ and
OQ is cosine for sure. This is cosine theta right here. If you guys look at your our diagram right here, this is the coheight that we've been working so hard to define. That is also known as the cosine. So OQ is cosine. Very nice, very nice. Okay, we got one more trig function. Come on, who knows it? Go ahead, Giselle.
PQ is sine.
PQ is sine, so this is sine theta. Now, you should be able to have two other labels on these, for two other sides on these triangles. Allie? OS is 1. You are correct, because that is the length of O to S. That is the length of the radius, and we know that this is our unit circle. Omar, do you have another one? OP is also 1. Very nice, very nice. Okay, so now we're just missing one more side. We're missing one more side. You got the cosine, which was this right here. You have the sine, which was this one right here. And you got the tangent, which is this one right here. The only side we have left is this one. OR, which is this side right here. That's more than one because it's greater. That's a bigger line than just O to P. What is that side called? That is, yeah, you're right, good guess. Secant. We call it secant because if we draw this line through this whole circle, it crosses it at 2 points. So we're going to call this the secant line. So the secant line goes right here. All right. Now you remember how we just reviewed similar figures? We just reviewed that? We're using that idea right now to help us understand what the heck secant theta is. So that's what this question says. It says use similar triangles to find the value of secant theta in terms of one other trigonometric function. One other trigonometric function. So now what you need to do is set up a proportion, because these are two similar triangles right here. Set up a proportion, two fractions equaling each other, to help us define what secant is. I'm going to let you guys try to figure that out with your group right now, and it's just going to be a quick 2 minutes, and then we'll see what you guys got. I'm going to walk around and see what you got. Now, if some of you guys set up proportions, and they're correct proportions, and some of you guys didn't, but you didn't try to make your job easier. Now, this is just a quick reminder. When you guys do proportions, the numbers that are on top of each other have to be related in some way, and the numbers across from each other have to be related in some way. So, if the numbers on top of each other, the numbers across from each other are related in some way, then your proportion is correct. How can sides be related? They either come from the same shape, like secant and 1. That comes from the same shape, so those are related. Secant and this one over here, those don't come from the same shape, but they're corresponding. That means that they come from the same location on the shapes, and so those are related also. So how can I set up a proportion that would help me find out what secant is? This is the way I would do it, because I want to know what secant is. I put secant theta right there, and then I'd compare it to 1. So I'd put these guys on top of each other. Because what is secant theta divided by 1? It is just secant theta. And so I will be able to find out what secant theta is. That denominator will just cancel out, right? All right, but what would that equal? What would the other side be? Remember, secant theta has to be related to something over here. So we look at the other triangle. Which side is related to secant? The 1 is. So we're going to put 1 right here. That's that one right there. And then which side over here is related to this 1 right here, which is right there? Cosine. So we're going to put cosine right here. So now you can say secant theta equals 1 over cosine theta. Now that's huge, because we just made a statement right here. We know what secant is, and that's huge also because now we can find out what secant is because we know what he is in relationship to cosine. So, for example, if we had a problem that says, what is secant 30 degrees? You would say, oh, well, that's 1 over cosine of 30 degrees. And do you guys know what cosine of 30 degrees is? Yeah, you should. What is it? What is it? It is rad 3 over 2, right? And so now we can simplify this some more. 1 divided by rad 3 over 2. We can write that out like this. 1 divided by rad 3 over 2. How would you do that? When you divide by a fraction, you just multiply by the reciprocal. So we have 1 times, what is it, 2 over rad 3. Yes? Yes. Okay. So then I just have 2 over rad 3, but we can't leave the radical on the bottom because this is algebra 2 trig. And we instead go and multiply the top and the bottom by rad 3. On the top we get 2 rad 3. On the bottom, what is rad 3 times rad 3? 3. Correct, because rad 3 times rad 3 is 9, and so rad 9 is 3. So this would be your answer. So, I mean, I went the long way to try to explain this to you guys to help you guys see where it comes from, but there is a shortcut actually. If you have a secant 30 degrees, you can just think, okay, what is cosine of 30 degrees? And you would think of that really fast, and you go, oh, that's rad 3 over 2. And so all you need to do is flip the rad 3 over 2 and then simplify it. Here, let me give you another example. Let's go to your chart, though, to fill that one out. Okay, so here's our chart. If we had, let's say we have a cosine of 60 degrees. That's this guy right here. Do you guys know what cosine of 60 degrees is? Yeah, that's 1/2. All right, so what would secant of 60 degrees be? Remember, secant is the reciprocal of cosine. So that would be 2 over 1, which is just 2. So just like how secant is the reciprocal of cosine, cosecant is also the reciprocal of sine. So, actually I want to do the sine first. So what is sine of 60 degrees? You guys know that? What is it? What is it?
Rad 3 over 2.
Rad 3 over 2. So what do you think cosecant of 60 degrees would be?
2 rad 3.
2 over rad 3, right? But then we have to do the thing where we multiply the top and the bottom by rad 3. And so we get 2 rad 3 over 3. All right, now there's one more thing I want to talk about before I let you guys finish filling out your chart, and that is cosine of 90 degrees. You guys know what cosine of 90 degrees is, right? What is cosine of 90 degrees? 0. Okay, so if I was trying to find secant of 90 degrees, I would have to take the reciprocal of 0. If I took the reciprocal of 0, what would you do?
Switch on.
It'd be 1 over
0.
0. And what is 1 over 0 equal to?
0.
No. We can never, ever, ever divide by zeros. So this is undefined. So secant of 90 degrees is actually undefined. All right. So I want you guys right now to take the time to find. Well, you guys already found these. You guys haven't filled out. You need to find the reciprocals of each of those so you can put them in the answers for your reciprocal trig functions.